let's just get this out of the way. It's not new hardware, it's software, but I'm so excited to show it to you today. We've been working on an idea for about a year now, and it also incorporates a bunch of our previous best ideas. So a bunch of great older ideas that we had, like graphical Wi-Fi scanning, and density view wasn't exactly our idea, but we kind of applied it in Wi-Fi. Oh, was it?
We did quite a bit of stuff.
Yeah, okay, cool. Airtime-based packet analysis with multi-layered pie charts. Those are some of our great ideas, and we've got some new ideas, and we just kind of took everything and put it into one tool. And I'm really excited to show it to you today. But first, before we jump into what it is, I want to talk about kind of the problems that we're trying to solve. I interviewed a bunch of wireless network engineers and got like 30 pages of single-spaced bullet points and figured out what are the biggest problems that wireless network engineers face when they're trying to do packet capture and packet analysis. And so we built a tool that we think addresses those problems. The first one is that capturing involves multiple manual steps. Right now, like even with IPA, you plug in adapters, and we support USB packet capture on Windows with like 15 adapters or so, like the good old Odroid, good old ComFast, some rebranded ones all work. But right now, even with IPA, you have to plug in a bunch of adapters, you have to start up your packet capture program, you have to figure out what channel to capture on, or channels to capture on if you're trying to get like a roaming event or something like that. And then you have to start the capture, go reproduce the problem, walk back and forth a couple of times or whatever you're trying to do, and then stop the capture. And then, only then, can you open up the packet capture in your packet analysis tool and look and see if you captured the problem. So it involves a whole bunch of manual steps, and there's almost zero instrumentation during the capture. You get a timer, maybe, like how long you've been capturing for, how many frames you've captured. That is typically, even in IPA, that's about it. That's usually all we get. And up until this point, I was okay with that, until we realized, hang on, there's something we can do here. There's something we can do to make this a little bit better. You have no idea what you've captured, and even once you get that capture, you have to scroll a massive list of packets, and you're doing regular expressions in Wireshark, and you're doing all this stuff to try to figure out where's that association request that I'm looking for? Where's that authentication that I'm looking for? Where's that four-way handshake? And so we've come up with something that we think addresses this problem as well. Also, it's difficult to get captures from a technical perspective. You have to be a fairly technical user to understand how to get a packet capture, how to be on the right channel, so on and so forth. And so we wanted to build something that is not only built for you, like this audience is what we built this tool for, but also something that you can hand to a junior technician and go, hey, go click on this thing, and you get the packets that you need. So the name of the product, we went back and forth on this for ages, but we found a name that we think is pretty cool. The new tool is called Tonic. And so MetaGeek Tonic is what it's called. So what I'm going to do now is just give you a quick list of features, and then we're going to jump into a demo. And then after the demo, the salesy part of the presentation ends, and then Ryan jumps in and tells you how it all works, which is probably going to be the interesting part. So it features what I call a WYSIWYG packet capture, or what you see is what you get packet capture. It also does automatic adapter management, so you can plug 1, 2, or even 3 adapters into it. We'll probably get to 6 at some point. There's obvious limitations with USB, so we kind of have to be careful. Dark Matter talked about that, right? We have to be careful about what we can actually shove through USB, but we think we could probably do 6 adapters at some point. We do automatic event detection. So let's say something associates to the network. We just pop an event and say, hey, we saw an association from this client, and I'll show you that. We also have a new visualization that I call packet flow. I thought it was totally original, that nobody had ever put this in a tool before. And then somebody was like, oh yeah, you mean like the packet flow for TCP IP and Wireshark? I was like, there's no original ideas anymore. But nobody's done it for Wi-Fi, and I'll show that one to you. We also do channel usage statistics across multiple layers. So we pull in some data from the Wi-Spy. If you decide to connect to Wi-Spy, you get Wi-Spy data in there. If you don't, no big deal, it just doesn't show up. And we also show you airtime usage. So you get both layer 1 utilization, and you also get layer 2 airtime usage all in the same tool. And I've really enjoyed being able to compare those two. We also give you the ability to export PCAPs really quickly. So now I'm going to jump into the demo and just show you what it looks like and what this thing is like to use. So Ryan, how long ago did we finish the build on this?
This build right here was built at, what time is it now?
2:40.
2:23.
2:23.
Out in the hall.
Oh, it was so close. to being a 2, 2, 2, 2, 2, 2, 2, 2, 2. So close.
If it crashes, just clap. We'll go on. It's probably going to crash somewhere in here.
It's probably going to crash. Even more likely than crashing, it's probably going to hang, most likely, because it works awesome at your house with like 20 clients and a handful of APs. You get in here with hundreds of clients, and yeah, things go crazy pretty quick. Okay, so we're stuck on demodulating frames. So,
there for a minute. Just give it. Yeah.
I almost quit. Okay, cool. So it looks a lot like a Wi-Fi scanner, but we're actually doing full packet capture here. So in the upper right-hand corner of the screen, you see these 3 little indicators. These are what our PCAP adapters are currently doing right now. There's a green, a purple, and a blue one. And you can also see there's a little line here that kind of skirts along underneath each channel, and that shows you live where that packet capture adapter is. Now, if you have one adapter, that one adapter is just going to go stripe back and forth. They'll just do 2.4 and then 5 and then 2.4 and 5. The point of this is that we actively manage what the adapters are looking at depending on what you are viewing in the application. So we see a whole list of ESSIDs here, but that's actually not where I'm going to start. I'm going to go to the channels view, and this just gives me a list of channels. Now there's a bug here, and in front of some audiences I might try to like pretend that there isn't a bug, but there's a bug. The airtime usage column is not right. Something is very, very broken there. We've been doing airtime calculations with packets for a very long time, so I'm super confident that we just have something plugged in wrong. Like Ryan said, we built it 20 minutes ago. But what I love about this is not only do you get layer 1 spectrum utilization for channel 1, you also get layer 2 airtime usage. And I love being able to compare those two and look and see how they follow each other around, or maybe how it's something that's not Wi-Fi, it's causing channel utilization on that channel. I've always wanted to be able to compare these two values, and hopefully you've always wanted to do that as well. We also show you on each channel who is causing the most utilization. So the ESSID WLPC is causing the most airtime usage on channel 48. So the next thing that we can do is go to the networks view, and I'm just going to drill down into the WLPC SSID. So now we're looking at all the radios that are part of the WLPC SSID, and we also get airtime usage for each one. I'm actually going to sort and see if I can find one. Oh, Ryan, we must have really broke airtime usage. Yeah, we broke airtime.
If you sort by clients, you can see the big client ones.
Oh, we got some of the 38 there. Yeah. Okay, so we can see like how much time, there's supposed to be a purple bar there that tells you how much airtime is being consumed by that specific BSS, all the AP and all of its clients. We also surface any events that occurred. Now, this one has 39 clients on it. I'm not going to click that one. You know why? It'll crash. It'll definitely crash. So we're just not going to click that one. Instead, I'm going to go look at, let's go take a look at this one with, we need one with what, less than 10-ish, right? We'll fix it, don't worry. Here, let's go look at this one with 4 clients on it. So this is an AP with 4 clients on it. You can see them all listed there. And again, the airtime usage bar chart is totally broken, but the airtime usage pie chart is working. And so you see there's a blue client there that's causing most of the utilization on this channel, and we split it out by what kind of traffic is it. Is it data frames? Is it control frames? Is it management frames? What is actually causing that overhead? And then from here, we can actually drill down to a specific client, and we can see specifics for that client, including a bunch of events that have occurred for this client over our selected time span. When I opened this up, I had a 30-second time span selected, so I boosted up to 10 so we could bring them all in. Although we're planning on changing that, we're going to keep events in there even after they roll off of the selected time span. So we get a multi-layer pie chart just like you're used to seeing in IPA. Here's our data frames, here's our control frames. We've got some null data frames, some quality of service frames, but we also live get a count of how many frames we have captured from this particular device. It's basically the AP client conversation. So as you can see, ACKs are counting up. We have about 900 ACKs. We've got about 1,200 block acknowledgements. We've seen 2 probe requests, 2 EPL, or one handshake, basically. We've seen a neighbor report. So we surface all the frames that you have captured while you're capturing. By the way, this is every single frame that we capture is going into a 10-minute buffer. We set 10 minutes as like an arbitrary thing. We just said, let's just go with 10 minutes and see how it does. Maybe we could boost that, probably can, but we just keep 10 minutes worth of frames in memory at all time. And if you want these frames, all you have to do is hit File and Save PCAP, and it just saves every single thing that we heard throughout the session. So then the next thing that we can do, and I'm really excited about the ability to look at how many frames we've captured. This is great. How many times have you wondered if you've captured that frame or not? I love toggling Wi-Fi off and back on my iPhone and watching it disassociate, watching it re-authenticate, handshake, eat frames, all that stuff happens. It's so much fun to watch it happen in real time. Now, the next thing that we can do is we can actually drill down into these events to see what happened when this event occurred. So for example, we can see that this client device sent a probe request. So we basically right now just have, it's super simple. We have a trigger frame. If we see a trigger frame, then we pop an event. We've got a bunch of different ideas for other types of events that we can bring in. But we see the event and we pull those frames in and show you a very simple list of all of the frames that were received. So you can see there was a probe request. We saw a QoS frame, a block acknowledgement. So we could see that client doing some stuff. Right now, we take the trigger frame, we pull 50 frames after it. Super duper simple, but it gets the job done. Now, what if you want to do deeper analysis on these frames? Well, if you want, you can click on the frame to drill down into it, and we'll give you a basic decode of this frame. Now, one thing that we were deliberate about is we put the decode in a bubble. And what I love about bubbles like this is you can change them depending on the type of frame. We can do what we call a contextual packet decode. So based on the packet, we can just surface the thing that's interesting and ignore all the other stuff that we normally don't care about. Like for example, in a data frame, what's the thing we care about? I'm usually looking at MCS. That tells me so much about the health of the client and the channel and what's going on, how things are going. And so we've got MCS here at the very top of the list. And by the way, Ryan added this on the plane yesterday.
That was on the plane.
Yeah, that was on the plane. We got that in there. So all kinds of things. Yeah. One thing that's great about WLPC is, and I've talked to multiple people doing deep dives, WLAN-Pi project, all this stuff, is you have to get it done by WLPC. And so that has really accelerated the development of this product. It's been super duper fun. Okay, so we've got the event here. Let's go take a look at a couple of other ones. Here's our four-way handshake. So there's handshake 1, ACK 2, ACK 3, RTS, CTS. There's all of our frames. We also have a neighbor report. Did we get Decode in for the neighbor report? Not quite. We're working on it though. We're really excited to get neighbor report in there. And you can see that we also popped an event for the neighbor report itself as well. Now, what if this is nice, but you really want to get this to your favorite packet analysis tool? What if you want to get it to Wireshark? What if you want to get it over to IPA? What if you want to take it over to OmniPeak? Well, what you can do is come up here to this little floppy disk icon, and I insisted on a floppy disk. Some of you know me, you know that I'm gonna insist on a floppy disk. From here, you can hit send to Wireshark, send to IPA, send to OmniPeak. I don't have it installed, but if you had it installed, that ungrazed, and you can hit send to OmniPeak. And it basically just writes out all of those packets, and they open up in, oh no, you don't have the color profile. We didn't, oh well. Missed that one. There's a color profile that matches, and so all the frames are colored perfectly, and what you would have seen, if that's the only thing that breaks in this demo, I'm gonna be super duper happy. But basically, we take all those frames, we write them into a PCAP file. They're thrown in a temporary folder, and so if you want, you can go back and grab it later, but it's basically 2 clicks to get this over to your favorite packet analysis tool. Okay, should we do a little live, like messing around with stuff?
I actually forgot my phone in the back.
You forgot your phone in the back? I think we can do okay. What do you think?
We should show the Keith feature though too.
What's the Keith feature? Yeah, you show it.
Yeah.
Is your mic on?
It is supposed to be. It's on.
It's just for you. Just for you.
Keith, you've always wanted an MCS graph. There you go. Client, AP, MCS.
So one thing that we did is, oh, thank you, Keith. One thing that we did is we separated out.
That one, sorry.
What's that?
You're the only one that wanted it?
Yeah, well, hey, it's just for Keith. So, I mean, he puts on the whole conference, so we can build a feature in for him. So these time graphs are dependent on what you're viewing. Like if you're viewing an ESSID, you get a certain set of graphs that are available. If you're viewing a client or a BSS, there are different sets of graphs. You can reorder them however you want. So, if you're Keith and you're like, I really care about client MCS, you can bump that one all the way up to the top. And if you're like, I am also Keith and I don't care about signal strength because it's all about MCS. I don't know if you actually say this, Keith. I'm just making stuff up here. But you can bump those up to the top, and you can basically reorder those graphs however you want to track things over time. It's a 10-minute time span right now, but we have plans for making it a little bit more dynamic, scalable, things like that. That's the kind of thing that we're looking forward to working on in MetaGeek Tonic. Okay, let's do a little live exercise really quick, and this might break everything, but you see the little events column here? This basically shows for that object, in this case, we're looking at a list of, let's just start from the bottom here. So we'll go all the way down to networks. We could click on the WLPC ESS, and then we could see all of our different BSS IDs here and all of the events that have happened to clients within those BSS IDs. So if y'all don't mind playing along a little bit, if you've got like your phone or something, can we just, like, I don't know, turn Wi-Fi off and back on again? I just want to see a whole bunch of associations show up. You don't have to participate if you don't want, but maybe it'll be kind of fun. So everybody ready? Let's do it in like 3, 2, 1. Okay, Wi-Fi is now off. Okay, and then we'll turn it back on. Some people jump the gun and turn it back on. That's okay. And what I'm hoping to see is a whole bunch of, oh, we got like, I saw a couple. Got a neighbor report. Okay, I can tell which APs everyone is associated to in this room. So it's those top 4 are the ones that we're all associated to in this room right now. So from there, we can basically chase down a client and say, oh, this one associated, it roamed. I just like that pie chart, looks really pretty. And we could click all the way down to it, and here's all of the events that have occurred for this particular client. Clients view and then done, probably. Like just to show you can look at a list of clients?
Yeah.
Okay, cool. And then your turn?
Okay.
Okay. So another thing that we did is we put in a clients list. So this is just a list of all the clients that we can hear right now. And you can see which network they're associated to. Some of you are on Hilton Honors. And I guess I clicked something on accident. Basically from there, you can drill down directly into a client. So if you see, I think sorting it by, it's making it jump around too much. But if you're interested in, for example, this client, you can drill down into it. You can also search for one. Like for example, if we say Ryan, oh geez, your keyboard is very different from mine. Okay, so Ryan has applied aliases to his clients. And so you can see Ryan's HP Spectre right here. Video output works from it, unlike my MacBook, which is really nice. And Ryan's iPhone, so we can actually just click on Ryan's iPhone and go straight into that device, which is doing tons and tons of probe requests. It's just sitting there probing right now. So it's really nice to be able to jump down into something very, very quickly. And of course, you can apply labels to all this stuff. You can go through and say, oh yeah, this MAC address is this is a certain AP. This MAC address is a certain client. And we're also thinking ahead to the future about how it'd be really nice for you to be able, I don't know, throw like a CSV file at it or something like that. And one thing I'm really excited about is I would love for you to be able to write aliases in MetaGeek Tonic and then push those to the Wireshark ethers file. So now when you open up Wireshark, colors are there, it all matches, and you also have a nice up-to-date ethers file, and you don't have to cat a bunch of stuff into the ethers file whenever you want to add something to it, and restart Wireshark, which I guess you'll still have to do even after we implement that. So that, in a nutshell, is a super quick demo of MetaGeek Tonic. So now I'm going to pass it over to Ryan, who is going to talk technical stuff.
Awesome, thanks, Joel. Is my mic working okay? No. Move it down. Is that better? Yeah. Okay, cool. Awesome. Okay, where are my slides?
By the way, I can't believe that basically nothing broke. That's amazing. I was really expecting it to break. Oh, forgot a couple things. $500. Boom. Sorry, I forgot about that. Can you go back one slide? Okay, so for $500, I'm framing this a little bit differently. This is the really salesy part of this. So what we're going to do is we're going to bundle up Tonic, IPA, and Channelizer. IPA is going to be reserved as like the deeper analysis tool, whereas Tonic is kind of the live, looking at events kind of tool. And so what we're going to do is just bundle these 3 tools together and call them MetaGeek Enterprise Suite. And for pricing for it, you just get all 3 tools for 1 year for $500, and that's it. So that's where we landed on pricing. Okay, now the salesy part is definitely over.
Okay, let's get techie then. Okay. One thing that we do in Tonic that's different than Wireshark, Wireshark, you just get a list of MAC address, send a packet to this MAC address. And we want to say, well, who is that MAC address, right? And so we wanted to say, how do we determine what the MAC address is? The first thing we want to do is look at beacons. And obviously, if you see a beacon, it came from an AP. But they only beacon 10 times a second. So I put in experimental code to look at RTS, because RTS should be sent to the AP, right? So the receiver of the RTS should be an AP. Does everybody agree with me? It doesn't work. And hopefully somebody can tell me why it doesn't work. But it was just a giant mess when I tried to do that. We had clients that were switching and were saying, oh, it's a client. No, it's an AP. No, it's a client. Because I had this chunk in there about RTS. The receiver of the RTS must be an AP. So we took that out. So now we can say, if you sent a beacon, you must be an AP. If you talk to an AP, you're probably a client. And there's probably situations where this doesn't work. But for now, that's what we do. So when we're looking at a packet, now we can say, well, here's an AP and here's a client. So you have a little bit more context about the conversation. Then we want to build the BSSIDs into a full AP. So this is the AP that's nearest my hotel room. All the BSSIDs that are on that AP. One thing that's nice about Ruckus is the first 3 octets, which is the OUI, are always the same. So you can always tell that it's a Ruckus MAC address, because you can look at the OUI. And then they're switching only 2 bits. And so 2.4, these are all 8, 5 GHz, these are all C, and they're flipping this bit right here for which SSID it is. So it's really clean. It's easy to take a list of MAC addresses for Ruckus and put them together and say that's an AP. Adrian, you've dealt with this, right? Yeah. Yeah, so here's the Ubiquity one. Ubiquity is a mess. They just randomly change bits. And so actually the 7483C2 is the Ubiquity OUI. But then they change it to 76 on a bunch of ones, so you don't actually know if it's a Ubiquity or not. So you just have to just grab a bunch of MAC addresses, you don't know what they are, and test and see if they're a Ubiquity address. Because then they change these bits over here. It's really a mess. And every vendor seems to have their own algorithm for doing this. And so I want to shout out to Robert and Wes from MIST for actually sending us their documentation, so we just know exactly what MIST does. And a lot of the other ones we sort of have to guess and everything. But what we want to do basically is just build up the AP. And so we can say, this is a client, this is an AP, here's all the BSSIDs that are beaconing on that AP, and that's one physical device. Right? Then what we said is, it'd be nice to know what kind of AP that is. Not just that it's Ruckus, but what model is it? So I went and Googled, because Google has lots of stuff, and actually found Google research from Google Labs that have a way to fingerprint clients based on their probe requests. So we adapted that for BSSIDs and APs. And basically what it says is, for each model, we'll take like a MIST AP35, it has a certain chipset, it has certain antenna patterns, it has certain capabilities, and every AP35 will basically have the same beacon signature. And the signature is made up of the information elements and the order of the information elements and the capabilities. You have to ignore a couple of information elements that are sort of transient. RSN and TIM are not always sent, but they can be sent. So we ignore those ones. And we basically come up with this fingerprint signature. So this is the signature of the AP that was nearest my hotel room. And I'm not sure if they're all the same. But every Ruckus AP that is this model should have the same signature. And what this basically is this is information element 0, 1, 3, 7, and then 221. 221 is vendor information element. And so then you put the vendor OUI and I think it's the tag value. And so this is a unique value for that information element. And then you have the capabilities for HT. There's like VHT capabilities and stuff in here. And so with this, whenever we get a beacon from that AP model, we know what it is. And this provides extra context. And Mike Spicer just put a note in here about evil twin detector. The tetra doesn't mimic the beacons properly. And so you can always tell if it's a tetra and not the actual AP that it's faking. OK, so now we have this kind of, we know who is talking to whom. Now we're going to look at how do we capture all these packets and how do we analyze everything. There's so many packets going by that it would be really hard if every single packet you updated the air times and packet counts and everything. So we basically chunk it into little time slices that are a few hundred milliseconds each. And so we put the adapters on a channel for 300 milliseconds. We gather all that information, and then we update our graphs from each time slice. So the graphs are only getting updated a few times a second. And that makes it much easier to kind of keep the graphs going and everything else. And on our adapters, there's a couple things that we're doing. Here's our kind of strategy for 2 adapters and then 3 adapters. We've tinkered with, in roaming, can we predict where the client's going and just jump to that channel so we can get all of the packets? It turns out the clients are really unpredictable. I assume you guys have seen that before. And it's really hard to actually know what channel it's going to go to. So currently what we're doing is basically keeping the primary adapter on the channel it's on, and the other two are just scanning around. And so if the client jumps to a different channel, we'll pick it up pretty quick, within a second or two. And that seems to work pretty good. And then we have different algorithms for what level you're at and what you're doing. So when Joel was saying if we report up to, if we could support up to 6, we would start putting adapters on the most likely channel it is for that client to roam to. And then on the packets, so Joel was saying we have a 10-minute buffer in here of packets. This is a chart showing the memory profile of the application. And we're trying to figure out, how much memory does this take for us to keep 10 minutes of packets in the buffer? And then it all depends on, obviously, how much traffic is going on. So this was this morning in the conference room. There's a lot of packets, lots going on. And so it's kind of track how much memory are we using. And eventually we'll get this more dynamic based on how many packets and how much memory we're using. But it is very interesting to be in this environment and test tools that you've only tested in your home environment. Because at home, everything works great. There's like 5 devices going. You get here, and yeah, the first time I fired it up today, it just crashed hard. Like, oh, crap. OK, and then Joel was talking about contextualizing packets. I think he covered most of this as far as the basics. And in events. One thing that's interesting in roams is it's kind of hard to actually tell every single time a client roams or if it didn't. And so we actually have some false roams in here. Because what we're trying to do is say, AP client 1 is always talking to AP1. But if it talks to AP2, it probably roamed. But that's not always true, because sometimes there's other packets that are going before an actual roam, or it's doing things. And so we need to do a little bit more work in here to actually kind of check for false roams, or this client's talking to a different AP than it normally does, sending out a probe request, that kind of stuff. And then Joel was talking a little about saving the PCAP. So in Tonic, we have a list of every single packet that's gone by in the last 10 minutes, which is hundreds of thousands, millions of packets. So what we do is event has a pointer into that list at its first packet, and then we can easily grab the rest of the packets that we need for that event. Oh, Joel.
Yeah. Sorry, I
think it was all the techie stuff. What else do I want to cover in there? Oh, there was something else, Mike, that I wanted to talk about before.
I thought you put it on a slide soon.
I did put on the slide for Evil Twin. I thought it was something else too, but I'll figure it out.
You can figure it out really fast.
Yeah.
No? Okay.
Nope.
Cool.
Yeah, so anyway, this has been a fun project, and I'm the software guy, so I just love to dive into all the deep stuff on the software side, but it is changing every day, and there's new stuff. And I am really curious on the RTS thing, if anybody can help explain to me why the receiver of the RTS may not always be a beacon, or sorry, be SSID. You got it? Excellent.
Awesome.
Thank you, Peter. Cool. I'll turn back over to Joel for the wrap and the whatever you got.
Cool.
CLZ.
All right. So I'm not going to read through the roadmap, but I just want you to know there's a big roadmap. There's all kinds of improvements we want to make. We crunched really, really hard for the past 3 or 4 months to get this ready. Now, one question that I know a bunch of you probably have is it coming to Mac OS? And I'd say, first off, please don't burn my house down. Find my address. Please don't. We're opening a closed beta today. I'll talk about that in just a second. Unfortunately, we're not to Mac OS quite yet. So we are planning to release on Mac OS with Monolith 2. Sorry, Monolith, that was a code name. Everybody knows the code name. It's fine. It's called Tonic. We called it Monolith for a very long time until we discovered the name Tonic. By the way, naming a product is like one of the most nightmarish things I've ever done. It is so hard. It is super duper difficult. But we were developing a version that was going to be completely cross-platform between Windows, Mac OS, and maybe even iPad OS. There's some interesting hardware that was just announced that would enable us to get packet captures on an iPad, so we're definitely thinking about that. But we realized there's just no way it's going to be ready in time for WLPC. And so, and additionally, another problem that we ran into is we're waiting for some key technologies from Microsoft to enable full cross-platform support. And so we're waiting on them. They're going to probably release that technology June or July, is I think last time we checked, is what it's looking like. It was supposed to be November. It's just gotten pushed out. It's OK. I know they're working to get cross-platform really, really right, and we're excited about that. So this version, Monolith 1.x, is going to be Windows only, but we are fully planning on supporting Mac OS with version 2. So real quick to wrap up, if you want to learn more and get your hands on it, we can probably give you a beta copy tomorrow-ish?
Sure.
Yeah? Yeah, OK, cool.
Tomorrow.
Yeah. But we are accepting people into a closed beta. The only thing that you need to do is come to our vendor evening thing and hang out with us for a little bit. Like we said earlier, we have those really nice mirror coffee cups. We have 28 of them. So what's that?
We have a Windows machine.
And have a Windows machine. And also, you need one of our supported PCAP adapters. So we have a list on our support page of there's about 15 different PCAP adapters that we support. The good old ComFast. Remember these? These work. It's 2x2 is not awesome, but hey, it'll work. You can see some lines moving around, and these work. So if you have these with you, these are a great way to get into it. And of course, you can plug in a Wi-Fi if you want. So that's in Navajo at 7 p.m. And also, if you want a Wireshark profile, we've just released the Wireshark Configuration Profile 2, and that includes the new colors from Monolith. We have an actual UX designer, and he helped me pick out a bunch of colors, and we got things looking really good. And so if you want to check that out, just go look at our Twitter, and you'll see the link at the top of our profile. So thank you very much for checking out the thing that we made, and enjoy the rest of the conference.